Hello, everyone. Glad to be here. My name is Fernando Jimenez. I am a security escalation engineer for the VPN team. And I'm here to talk about troubleshooting Cisco Secure Client with SAML single sign-on on Secure Firewall. So before we start, I would like to talk a little bit about myself. I have been working at Cisco since 2016. The first technology that I worked with was LAN switching. So I became expert in troubleshooting issues related with layer 1, layer 2, and layer 3 issues on the Catalyst switches. But my passion was always with the security stripes, and I always attracted by the VPN. So I moved on to the VPN technology on 2019, and I have become expert on all the flavors of VPN that you know: site-to-site, remote access, DMVPN, FlexVPN, etc. Besides that, I'm passionate about soccer. I support Liverpool. This season was not so great, so shame. Also, I love playing soccer, mountain biking, and I am a pet lover. So that's me. And this is the agenda for today. We will start with a brief introduction of the topic. Eventually, in order to troubleshoot issues related with SAML, we'll need to understand the communication flow for SAML authentication, know the SAML components. We will review a very basic configuration example on Cisco Secure Firewall, and eventually we will get to the main point of the presentation: troubleshoot common issues. At the end of the session, we will have a brief session of question and answers. All right. So before I started working at Cisco, I used to work on a very small telecommunication company, like 2 months as an intern. So I do remember when I wanted to access different applications, it was a pain, to be honest, to access to the web browser, to the email, to my phone services, using the same set of credentials. But eventually, when I started working at Cisco, with the help of single sign-on, that was no longer an issue. So I access to different applications using single sign-on. Okay? But what is single sign-on? Single sign-on, or better known as SSO, allows users to access multiple applications by signing in with one set of credentials. Okay? This prevents repeated authentication in order to access different applications, or when a user is disconnected from a single service. Okay. One type of single sign-on authentication protocol that we have, it's SAML. SAML stands for Security Assertion Markup Language. So SAML is an authentication XML standard for authenticating web applications. And it simplifies the login experience and allow single sign-on, allow to access multiple applications with one set of credentials. Okay? So since it is an XML-based framework, this ensures and this helps to exchange authentication data between the security domains. But what are these security domains? So the security domains are composed by 3 agents. We have the user, service provider, and identity provider. These 3 agents need to communicate between each other, creating a circle of trust. Okay? But how this communication works? Well, we need to go and understand the communication flow. In this example, the user is represented as a web browser and Cisco Secure Client. The service provider will be the Cisco Secure Firewall, and the identity provider will be the Duo server. Okay? First on, the user will access to the portal to the service provider or the Secure Firewall. Eventually, the authentication request will be redirected using the web browser of the user back to the identity provider. Duo will challenge for the credentials, and us as user will enter our credentials. At this point, the identity provider will verify if the user will be authenticated or not, and eventually will send out an HTTP post message using the user's web browser back to the service provider. At this point, the service provider will say to the user that you are logged in, or if not, well, authentication failed due to credentials. Okay, I would like to highlight 3 main points for this communication between the service provider and identity provider. The first one, service provider do not directly speak to each other. But all the SAML data is being redirected using the web browser of the user. So at this point, it is important to highlight that the user needs to communicate to the service provider and to the identity provider. Similarly to the single logon communication flow, we have the single logoff in order to log off from our session. It's similar. As you can see, the user will request a logout session to the service provider. The SP will redirect that logout request to the identity provider, and eventually the identity provider will send out the logout response back to the service provider, and we will be finally logged off from our session. Okay, now that we have reviewed the communication flow, we'll need to understand the SAML components. What are needed in order to form this SAML authentication? Okay, SAML is an XML-based framework, and it uses a metadata. This will ensure a secure transaction between the identity provider and the service provider, and it will negotiate the agreements between these security domains. In this example, we can see an IDP metadata. There's a bunch of information here, but if we look closely, we can start identifying some SAML components, such as the entity ID, certificates, and our services URLs and SAML bindings. As well, the service provider needs to have a service provider metadata. And here are some of the SAML components. But what are those SAML components that we have? We have the entity ID, services URL, SAML bindings, and certificates. The entity ID is a unique identifier for an identity provider or service provider. Here on the right, we have the highlighted in orange, yellow, the URL of the entity ID. Similarly to the service provider, we have the entity ID. Okay, the service URL. As its name states, it will provide a service, and we have these three services: the single sign-on, single sign-off service, and the session customer service. This last service is only found on the service provider metadata. And if you recall from the diagram, when the identity provider receives the credentials from the user, it will send an HTTP post message back to the service provider. So that is when we use the session customer service URL. And how are we going to exchange or redirect this data? With the help of the SAML bindings. The SAML bindings are the method to transfer this information between the security domains. And we have HTTP redirect, the HTTP post, as we saw in the diagram, and this last one, HTTP artifact. This last binding is not supported on the firewalls, on Cisco Secure Firewall and ASS. So we are going to focus only on the HTTP redirect and HTTP post. So we have here our metadata of the IDP and the service provider. As you can see here on the green side, on the left side, we have highlighted in green the single sign-on service. We see the location, URL, and the binding here. It's using an HTTP redirect to single sign-on the user. Okay, and as mentioned on the service provider metadata, we have the session customer service. We have the URL and the binding, which is an HTTP post. Since we are exchanging this information between three main agents, this communication needs to be secure. Therefore, that is why certificates are needed in order to encrypt and sign this information. And the identity provider will have the certificate, and as well the service provider will have its own certificate to exchange this data securely. Okay, so we're going to see really quick the configuration example on Cisco Secure Firewall. But if you want to see more deeply the configuration, you can download the presentation and you can look closely. As well, we will have the equivalent configuration on Cisco Secure Firewall Management Center and the CLI for your reference. The first thing is that we'll need to install the certificate of the identity provider in the firepower. This is done manually. Enrollment type is going to be manually, and we retrieve this certificate from the IDP metadata. As well, we'll need to install the certificate of the service provider. And this can be a self-signed certificate or a certificate signed by a CA authority. As well, we'll need to configure the SAML server. So we'll need to collect all information from the IDP. And we'll need to ensure that we have the identity provider entity ID, single sign-on URL, logout URL, and the base URL. This base URL is going to be the entity ID of the service provider. And as you can see, we have the certificates that we have installed for the identity provider and the service provider. OK, once we have all this information, we're going to create a remote access VPN profile. So this is done by configuring everything as normal, but the main point here is the authentication method. We'll need to highlight or select that we're going to use SAML for authentication and specify that we're going to use the authentication server that we just created on the single sign-on services. OK, now to the main point of this presentation. We have understood how the communication flows for SAML authentication works and the SAML components. So we're able to troubleshoot the most common issues for SAML authentication. But I would like to highlight that most of the common issues related with SAML authentication are due to misconfiguration. So the first thing that we'll need to do is to ensure that the configuration matches with the one that we have on the identity provider metadata and the service provider metadata. There are going to be times that the configuration will look fine, but if we're not able to determine the issue, we can start running debugs. So we have the following debug output that we can use in order to troubleshoot those issues. And these debugs are going to be run on the CLI of the FTD. The most important debug that we're going to use is debug web VPN SAML at level 255. This will provide a lot of information and determine and point us of where the issue is located. This is an output of a successful authentication method. And we have here the diagram, and since we're putting the debugs on the service provider, we're going to see that we are building an authentication request that is going to be redirected to the identity provider. Similarly, we are going to collect information when the identity provider sends out the customer assertion or the authentication response back to us, to the service provider. This is how the whole output of the SAML authentication. And we can see here that at the end, we will have an authentication successful. OK. One of the most common issues that we have is entity ID mismatch. So as I mentioned, we can see that is due to a misconfiguration. So in this example, we have that the Cisco Secure, SAML authentication has just been set up. It's a new setup. And us as network administrators, we have complaints from end users that are not able to authenticate. Someone else put the configuration, and we do not know where the issue is. So we enable the debugs. Debug web VPN SAML 255. And the debug output that we have is this one. We're going to focus on the highlighted in red. The identifier of a provider is unknown to LATSO server. Okay. This debug output means that there is an entity ID mismatch on the secure firewall, and it's not matching to the one that we have on the IDP metadata. The action that we'll need to check or to do is to verify that the entity ID matches to the one that we have on the IDP metadata. OK. So in this example, are you able to determine what's the issue here? Come again? Yeah, correct. So someone else missed out the A. And the action that we'll need to do is to configure again the entity ID on the single sign-on server settings on the firewall. After we perform this action on the FMC and deploy the configuration, we are able to authenticate successfully. This is one of my favorite scenarios, and it's pretty common, time mismatch issues. In this example, we have a Duo server, and multi-factor authentication has been implemented. It means that Duo will send out a push to the user, and the user needs to confirm that push, and it takes some time to answer to that push. So we're having issues and enable the debug output. We get the following debug output. And first thing that we'll need to do is focus on this debug output. Assertion is expired or not valid. So what this usually means is that there's a time synchronization issue between the Cisco Secure Firewall and the IDP. It is not mandatory to configure an NTP server, but it's a best practice. And a best practice is that this NTP server matches to the one that we have configured on the IDP. So once we perform this action, still the end users are complaining that they cannot authenticate correctly using SAML. So we enable again the same debug output, and we get the same error. Now we're going to focus on this one. Not before that time, not an hour after. And we can see that there's a timeout value set to 0. So remember that we implemented multi-factor authentication, and there's a time that is running when the user needs to confirm that push. So the timeout value set to 0 is not allowing or is preventing the service provider to accept the customer assertion service. So the problem is that the assertion is not valid between the specified time. The action that we'll need to take is to modify the timeout value configured on the secure firewall. So if you remember on the configuration information, we have all this information for SAML single sign-on server, but at the end we'll have a request timeout. So we modify this timer from 0 to 300 seconds, and eventually this issue got resolved. If you're going to implement this change, we have the timer between 1 second and 7,200. So it will depend on your scenario and your deployment to specify the value that you want. This is another scenario that we have. Wrong IDP signing certificate. And I have received a bunch of cases regarding this issue. We have the dual identity provider server, and we have a connection profile that is working fine. All users are able to authenticate. But a new connection profile has been implemented for another set of users using the same IDP. These new set of users are not able to authenticate. And we are asking, why we are not able to authenticate if we are using the same IDP? So again, we run the debug output, and we get this issue. Failed to verify signature. We can determine and correlate this information and match it to a certificate. So I remember that at the beginning of this session, the most common issue regarding SAML is DUA misconfiguration. So at this point, the service provider or the secure firewall is not able to verify the message signed by the IDP. So probably there's an issue on the configuration, and we do not specify the correct certificate here. So we'll look at the certificate that we have with the help of this output, show crypto CA certificate and the name of the trust point. And I would like to highlight that we can determine if we are using the correct certificate by verifying the issuer name, the common name, and the subject name. As well, we can verify it with the validity date. Another option that we have is the certificate serial number. For this scenario, I noticed that I have an issue with the certificate and match it with the username, issuer name, the subject name, and the validity date. And here on the right is the certificate of the IDP. So I check the configuration and notice that on the single sign-on server settings, I put the identity provider certificate of the connection profile that was working. And this is the expected trust point that we need to put on the new connection profile. After this, the connection profile was saved, deployed, and users were able to authenticate correctly. This is not a pretty common issue, but we have it. Invalid assertion audience. Similarly, this is a new setup for SAML authentication, and users are not able to authenticate. We run the debugs, and we get the following output. Assertion audience is not valid. But we need to ask, what is assertion audience? Is to whom the customer assertion is intended for. So the identity provider is not selecting the correct service provider. At this point, the ADP is not defining the correct audience, and the action that we'll need to check is to verify that the base URL doesn't have any typo or is configured correctly on the IDP provider. This is the last scenario that we have of the most common issues for SAML authentication, and this happened with a case that I had a few months ago. Users migrated authentication from Radius to LDAP, Radius to SAML authentication using Duo. After this migration, users are not able to authenticate correctly. So I started running debugs, and I did not get any debug output after I entered the credentials. So what happens here? So what happens is that the HTTP post message that the identity provider is supposed to send to the service provider is not arriving to the service provider or the secure firewall. Okay? At this point, something might be odd with the customer assertion URL on the identity provider or service provider. So there are 3 actions that we can take. The first one, ensure that there is no typo on the base URL configuration on the service provider. Secondly, we can verify the service provider metadata and ensure that this assertion customer server URL is correct. And the third one is to ensure that the IDP has the correct customer assertion service configured. Okay, before we end the session, I would like to highlight 3 things that we need to do in order to troubleshoot SAML authentication issues. First one, understand the communication flow. How the user is communicating to the service provider and then to the identity provider. Identify the SAML components as well. In there, we can determine where the issue is if something is odd or bad with one SAML component, such as a entity ID, certificates, SAML URLs, etc. And debug is a powerful and useful tool. So if you have any issues with SAML authentication, please run the following debug output set. The most important one is debug web VPN SAML at level 255. But if you would like to collect more information, you can run the setup, the rest of the debugs. And thank you very much. Please fill out all your session surveys. It will help us a lot to improve for later, for the next Cisco Lives. And if you have any question, go ahead. Yep.
FDM supports the SAML authentication. Thank you. I know that FDM supports the SAML authentication. However, I ran into an issue with the certificate where the no CA check was required to be enabled, but FDM doesn't seem to support this natively. So I had to rely on a third-party software to regenerate a certificate of the box and then import it. Yeah. Is there any way to do this natively on the FDM itself?
Yeah, so there's an enhancement request open for that. So in the later versions of the FDM, that integration, that CA check will be enabled. But there's an option in order to bypass this issue, but it's using REST APIs. So
it's going to include that feature?
If I'm not mistaken, 7.4. That is intended to be released on November. Yeah, we can check it as well. If you have more questions, well, or yeah. Mm-hmm.
So our organization already has SAML IDP running. It's some VM somewhere in AWS or something. So that's what the AnyConnect would talk to. After it talks to the ASA, this is the AnyConnect, talks to the ASA. ASA talks back to the client and says, okay, let's do this IDP, this SAML thing. The client's AnyConnect session, client, which could be, they could be on vacation in Utah or Singapore or whatever. That'll talk to our IDP,
Yes.
then the IDP gets its credentials, it gets its assertion, sends it back to the AnyConnect?
Yeah, to the service provider. So eventually, those credentials are going to be.
Well, our IDP will then talk to the backend database to figure out who this person is.
Yes, correct.
And feed it, and it'll feed the person some HTML. Because does the AnyConnect pop up a little HTML window that shows the? Because when I log into ServiceNow, let's say, we have it integrated with SAML with our IDP.
Yes.
And I get a pop-up. It's branded with my organization.
Yes, correct.
So the AnyConnect client will pop that same kind of window up that's branded with our organization's HTML?
No. So basically, whenever you do this, remember on the communication flow when the authentication request is redirected and a new web browser is opened, as you mentioned.
Well, I haven't seen it work. Does it open up a web browser?
Yeah, it opens
so it
a
opens
web
up
browser.
a web browser, and then the web browser, if it's Chrome or whatever,
Yeah.
will present the organization's branded SAML screen. I type in my credentials. That gets sent to the IDP, it's at the IDP at that point. Checks it. Yeah, I got the right password. Sends the assertion to the AnyConnect.
Yeah, correct.
And then the AnyConnect will feed it back to the ASA.
Yeah, correct. And
And
it
then-
will display like you're connected to the AnyConnect and you're good to go.
And then the session's good.
Yes.
So how does Duo? I didn't mention Duo in any of that.
No, well, Duo was an example of IDP.
Okay.
So you can use Duo, Azure as well, Okta for IDP. So
All right.
basically, well, I did not mess with the configuration or deep with the configuration on Duo because that's a different topic, but yeah.
So then to spin Duo back into this conversation, because we do use Duo.
Yes.
Because we want it to bing the person's smartphone.
Yeah.
So it's been a while since I've done this kind of config myself, but I think the next part in the authentication would be the ASA would then talk to Duo, the cloud service.
Well, they do not directly speak. The ASA to the service provider.
Not the service to Duo.
No, the Duo with the Duo.
It doesn't talk to Duo anymore?
that's-
How does Duo get the signal that says, okay, this person has gone through the first section, they've authenticated, I now have to bing that person's smartphone? How does that next piece start?
Okay, so at that point, when the IDP receives the credentials, it will match it and verify the user's database and verify, okay, this has this phone, and Duo will directly speak to the person. That message,
The IDP will talk to Duo?
the IDP is Duo.
No, in our case, we have our own IDP.
Okay,
So once that IDP is authenticated the user, how does the IDP then send a signal to Cisco's Duo system?
no, I have a lab if we can we can check it on the booth, and we can verify how Duo verifies the database and sends out the pushback to the user.
All right. Yeah, if you had a demo somewhere
Yeah,
after
I
the
have
show,
a demo, yeah.
so that way we don't have to consume everyone's time. Did anybody else have any questions?